Welcome to The Explainer. Today, we're building a definitive decision guide specifically for procurement managers. We're tackling a choice that comes up all the time: how to optimize cable tray specifications for strict cost control and highly efficient installation space. If you're buying for large-scale infrastructure projects, you already know that every single millimeter and every dollar absolutely counts. So let's look at how these specification choices are really impacting your bottom line.
Let's kick things off by busting a massive and honestly incredibly expensive industry myth. Does doubling your tray width actually future-proof your project? As a procurement manager, it is so tempting to look at his spec, see a jump to a wider tray, and think, great, we're buying more capacity for the future, we're covered. It feels like the safe bet, right? But as we're going to explore today, that assumption can quietly sabotage your project's budget and create some massive spatial headaches down the line.
So here's our game plan for today. First, we'll bust that wider is always better myth. Second, we'll dive into the hidden costs of deflection and heat. Third, we'll look at some real-world space optimization and cost control strategies. And finally, we'll wrap up with a procurement guide looking at Xinma standards.
All right, Section 1. Busting the myth, is wider really better?
Defaulting to a larger size brings a very immediate structural reality. Sure, a wider cable tray absolutely doubles your usable area. That's just basic math, and it's true. But here's the catch: it also drastically increases deflection and cranks up the structural load. You aren't just buying a little more breathing room for your cables. You're actually buying a heavier, much more cumbersome physical footprint that places significantly more stress on your facility's entire infrastructure.
Balancing three specific parameters, rather than just blindly increasing width, is your true key to cost control. What engineers actually need to look at before specifying tray width revolves heavily around the fill ratio. Fill ratio, not physical width, is the true governing parameter here. As the person making the purchasing decisions, your goal is to facilitate a smart, three-way trade-off between the fill ratio, your realistic future capacity needs, and the required load class. If you only focus on width, you're completely ignoring the physics of the load class. And well, that leads straight to overspending.
Moving right along to Section 2, let's talk about those hidden costs: deflection and heat.
Okay, here is the bottom line when comparing sizes. Going from a standard 300mm tray to a giant 600mm tray means you are going to buy a lot more support hangers, and you'll be paying for closer spacing. When you double that width, the deflection, which is just how much the tray bends under the weight, changes dramatically. Because of that increased structural load, your installation team simply cannot use standard support spacing. They literally have to space the supports closer together just to handle the sag. What does that mean for procurement? Higher hanger costs. You're buying more hardware, paying for extra labor to install it, and burning through your budget just to hold up a tray that, frankly, might not have even needed to be that wide in the first place.
We also really need to define ampacity derating, because inner cables running too hot means you are effectively wasting the expensive copper cables you just bought. This is a fascinating and very often overlooked hidden cost. Wider trays can actually run much hotter, not cooler. When you pack a massive 600mm tray completely full of cables, those inner cables get trapped. They push thermal limits far above anything the outer rows experience. Because of this, engineers have to derate the ampacity, meaning those inner cables are allowed to carry less electrical current to stay safe. So think about it. You are paying top dollar for premium copper cables only to have their efficiency throttled by the heat trapped inside an overly wide tray. No way around it. That's just a waste of money.
All right, let's jump to Section 3, space optimization and cost control.
Here's a strategy that is an absolute game changer. Splitting a route into two narrower 300mm trays is very often the superior choice. Let's break down why. First, in terms of heat dissipation, two 300mm trays allow for far more airflow around the cables, which completely avoids that ampacity derating trap we just talked about. Second, for structural load, two narrower trays distribute the weight much more evenly. That saves you from having to buy heavy-duty, closely spaced hangers. And crucially, for space optimization, routing two smaller trays give your installation teams the flexibility to actually navigate around existing HVAC ductwork and maintain vital maintenance access. It's way easier than trying to force a massive 600mm roadblock through a crowded ceiling plenum.
The big takeaway here is that width decisions have to be applied to real routes with strict structural and access constraints in mind. Width is a structural and thermal decision, period. It is not just a straightforward capacity upgrade.
When you're reviewing purchase orders or tender documents, keep in mind that real-world facilities have unmovable HVAC constraints and strict physical access requirements. Opting for a wider tray without considering those spatial realities is basically a guaranteed way to drive up your installation costs and trigger mid-project redesigns.
Finally, let's move into Section 4, our procurement guide, and how Xinma standards apply here.
When you're sourcing for demanding environments, you need a vendor who truly understands these nuances. Xinma brings specific expertise right to the table, manufacturing cable tray systems, busways, seismic bracing, and intelligent cable management solutions. Whether you're procuring for high-density data centers, expansive rail transit systems, complex industrial plants, or modern commercial buildings, the vendor you select must be capable of handling the structural and thermal decisions we've discussed today. Shanghai, Xinma, Busway, and Cable Tray provides exactly this kind of engineered infrastructure.
Ensuring your vendor complies with rigorous international standards guarantees that your cost and space optimizations are built on a rock-solid, safe foundation. Xinma's products comply with major standards like IEC 61537, NEMA VE1, BSEN 50085, and GB 31251. As a procurement manager, requiring these benchmarks means that when you make an intelligent engineering choice, like splitting a 600mm route into two highly efficient 300mm routes, the physical trays you're purchasing have actually been rigorously tested. They're guaranteed to perform exactly as expected under those specific load classes and thermal conditions.
So I'll leave you with this final thought to challenge your next big project and encourage a smarter, space-optimized purchasing strategy. Is your current cable tray spec really saving you money, or is it just hiding future costs? The next time you see a massive tray size specified just for the sake of future capacity, remember those hidden hanger costs. Remember the thermal derating of your expensive copper. And don't forget the absolute spatial nightmare it might cause around your HVAC systems. Think structurally, think thermally, and optimize your procurement for the real world. Thanks so much for joining me for this explainer.